For a long time, we've thought about robot teams like they're puppets on a string, each one following a super rigid script. But what if we could just cut those strings? We're going to dive into a massive shift in robotics, where generative AI is literally turning those puppets into smart, collaborative players.
I mean, really think about that. What makes the championship team so great? It's not just about raw talent, right? It's the communication, the strategy, the ability to adapt when things go sideways. So what if we could give that exact same kind of intuitive teamwork to a whole fleet of autonomous robots?
And this slide just lays it out perfectly. On the left, you've got the old way, scripted puppets. They followed the plan, and if anything unexpected happens, well, the whole thing can just fall apart. But on the right, that's the new model, generative agents. These are strategic players. They can reason, they can adapt, and maybe most importantly, they can actually talk to each other to figure things out on the fly.
But to really appreciate how big of a deal this is, we gotta look at the old problem. Why has it always been so incredibly hard to get robots to work together?
Well, the old playbook was all about top-down control. Everything was pre-programmed with strict rules. They used things like task auctions, where some central computer would just hand out jobs. And look, that worked fine in a predictable place like a factory. But you throw them into the chaos of the real world, like a disaster zone or a busy warehouse, and those systems were just brittle. A single unexpected obstacle could bring the whole team to a screeching halt.
So, what's completely rewriting that playbook? You guessed it, the generative AI revolution. This is the absolute game changer that's finally cutting the strings.
It's such a simple idea, but it's incredibly powerful. We're giving these robots two things they've never really had before. A brain, a large language model that lets them reason about the world, and a voice that lets them communicate their plans and ideas to their teammates using natural language.
And this brings us to this really crucial concept, agentic AI. See, an agent isn't just a program that blindly follows your code. It's an AI that can actually look at its environment, reason about what it needs to do, create its own plans to get there, and then act on them, all by itself. We're moving from just programming robots to creating truly autonomous agents.
All right, so let's get practical. What does this new kind of teamwork actually look like when the rubber meets the road?
So first off, they don't just sit around waiting to be told exactly what to do. You can give the team a high-level goal, and the agents themselves figure out the best way to split up the work. They look at their own skills, they look at the situation, and they divvy up the tasks. It's a true divide-and-conquer strategy cooked up by the team itself.
And hey, this isn't just some theory. Check out this data. A recent system called Llama-P, which uses a large language model for coordination, had a 105% higher success rate on complex tasks than the old methods. Let that sink in. A 105% improvement. That's not a small step, that's a giant leap forward in what these teams can do.
Okay, so they can divide up the work. Great. But what happens when two smart, independent agents both want to do the same thing, or their plans clash? With the old puppets, that could mean a system crash. With these new players, they do something, well, something very human. They talk it out.
I mean, take this real-world example between two drones. Instead of just following some rigid rule, they actually communicate their intent. One drone says, "Hey, I'm going to turn right to avoid you. Sound good?" And the other one can understand and confirm. This is negotiation, and it's what allows for incredibly fluid and efficient teamwork, especially in really crowded spaces.
And just how good are they at this negotiation stuff? Well, get this. Meta created an agent called Cicero and put it in the game Diplomacy, a game that is all about trust, betrayal, and making alliances with other people. The result? It ranked in the top 10% of human players. This just proves that AI can master incredibly complex, social, strategic thinking. It all feeds into this constant cycle, this replanning loop. The team makes a plan, they try one step, they see what happens in the real world, and then they adjust the whole plan based on that new information. It means the team is never locked into a bad strategy. They're always learning and replanning together in real time.
So we've seen what these AI teams can pull off. But how do you actually build one? And where do we humans fit into all this?
So broadly speaking, there are two main ways to design these systems. A centralized system is kind of like having one big brain, a team captain that sees everything and tells everyone else what to do. Then you have a decentralized system, where every agent thinks for itself and teamwork just emerges from them talking to each other. And as you can see here, they each have their trade-offs. Centralized can make the absolute best plan,
But if that main brain goes down, you're toast. Decentralized is way more resilient, but sometimes the team can get a little disorganized. The big takeaway, though? Researchers are finding that hybrid models, which kind of combine a central strategist with independent players, they often get the best of both worlds and the highest success rates.
So what does this all mean for us? Well, the human's role is changing, big time. We're not the puppeteer anymore, pulling every single string. We're becoming more like a high-level coach, setting the overall strategy and the main goals for our team of AI players.
A human can now give a command just like this, in plain English. The AI team gets the intent, they figure out how to break that down into smaller jobs, they coordinate to get it done, and then they report back. We just provide the what, and the AI team figures out the how.
So let's zoom out for the big picture, because this isn't just about making better robots. This is really about the dawn of a completely new kind of intelligence.
This right here is the profound takeaway. We're moving beyond just individual smart AIs to create artificial collective intelligence. We're talking about groups of AIs that can solve problems together that no single agent, or maybe even no single human, could solve on their own. Now, of course, we're not totally there yet. There are some huge challenges ahead. I mean, how do you scale this up to swarms of hundreds or even thousands of agents? How do you guarantee they're safe when they're this complex? And maybe most importantly, how do we build in the ethical guardrails to make sure these teams always make the right choices? These are the big questions that researchers are working on right now. And that leaves us with one final and I think really crucial question. We are on the verge of creating teams of intelligent, autonomous agents that are going to work right alongside us. The technology is moving at an incredible speed. So the question we all need to start thinking about is this. As we build them, what kind of teammates are we going to teach them to be?